Hey, today we're going to talk about equilibrium, and we're going to talk about what happens to systems at equilibrium. So before I begin, you'll see this sign right here, and this symbol means equilibrium. We can have a reaction that's in equilibrium. So what that means is that the rate of the forward reaction is the same as the rate of the reverse reaction. That's all the equilibrium means. So if I speed up the forward reaction, I also have to speed up the reverse reaction. Another way you can think about it is when ice is melting. So you have, let's make this solid. Let's make this liquid. So basically, it's in equilibrium. If I have a glass of ice water, some of those particles may be in solid format in the ice cube. Some of the particles are going to be liquid water, but some of these particles on the ice cube are going to go from solid to liquid, and some of the liquid particles are going to refreeze onto that solid ice cube. It's going to be in equilibrium until the temperatures equalize. That's going to take a while. Now, when you see the symbol, forward equals reverse, the rate. Now, one thing that I would like to tell you is this principle called lechatellier's principle. He was a French scientist, and he discovered that when a system is at equilibrium and you add something to stress out that system, it's going to react in a way that relieves that stress. What does that mean? For example, let's say I add to this solution, I have A and B yields AB plus heat. To this solution, if I add a whole bunch of B's, that's messing up this equilibrium because now I have a lot more reactants and a lot less products. So if I add more B, I want to relieve the stress. So if I have an excess of B, I want to move the reaction away from the B. In other words, I want to reduce this because I have too much now. I want to get rid of some of it, so the reaction is going to go that way. Let's try another example. Let's say that I added a bunch of heat. Okay? So I add more heat. Now I have an excess of heat over here. I want the reaction to move away from that heat. So the reverse reaction is going to be favored in this situation, to get away from the heat. Okay? Now we've been talking about increasing the quantity of something, but if I were to decrease the quantity of something, like for example, let's say I lowered the temperature. So if I got rid of the heat, entirely, I need that heat to increase. And the only way for that heat to increase is for the reaction to progress towards whatever I lowered. So if I got rid of heat, the forward reaction would be favored. Okay, almost done. Now, last thing I'm going to do is, let's say I lowered the quantity of B. So I have less B. The only way that I'm going to get to make more B is by taking AB plus heat. It's going to drive the reaction that way to get more B. So I want to equalize everything. So again, when I lower the quantity, the reaction is going towards that lowered quantity. When I increase a quantity, it's going away from that quantity. So in this example, by the way, the left or reverse reaction is favored. Now we're going to show you this visually. And I have three different situations. So if you look down in the corner, right down here somewhere, if you look down in the corner of the screen, it's going to give you a reaction. So I have nitrogen plus hydrogen yields ammonia. Now this reaction is something that could be in equilibrium. So if I have nitrogen and hydrogen gas, it will progress towards making ammonia. If I have an excess of ammonia, it's going to go the other way. So in the first situation, if I increase the nitrogen, this is what's going to happen. Check out the graphic. So as I increase the nitrogen, That means there's more nitrogen. It's going to use up some of the hydrogen. So by increasing the nitrogen, the hydrogen is going to decrease. Look at the graphic. And the amount of ammonia is going to increase. The forward reaction in this situation is favored. Again, watch it one more time. Increasing the nitrogen, forward reaction is favored. Now let's look at the second one. The second one, I'm going to decrease the amount of hydrogen. Remember what I said, when you decrease something, it's going to go towards the deficit. So when I decrease the hydrogen, the reverse reaction should be favored. So decreasing the hydrogen, notice what's happening, is some of the ammonia is progressing towards the left and it's breaking apart into hydrogen and into nitrogen. Look at the graphic. Again, one more time. By lowering the hydrogen, I'm also causing the ammonia to decrease. I'm causing the nitrogen to increase. The reaction is favored towards the left. And my third example, graphically, if I increase the amount of ammonia, check out what happens. Increasing the ammonia means the reverse reaction is going to be favored. And the last thing that's going to happen is the hydrogen, notice, it's increasing, and the nitrogen is also increasing. Okay? We're going to be doing a lab. Maybe you should make this a little bit more clear. I want you to use this equation, and I want you to answer this practice question. Okay? Peace out.